Hi, how are you today? Today we are going to continue with our lesson, but today we will focus on the navigation, which is specific for the line following robot. So, as an autonomous mobile robot, it must has the ability to determine its own position in the environment. Okay, it must know its surroundings. And then to know its surrounding, sensors must be used in order to capture those data. Okay, so by knowing its position in the environment, so it makes the autonomous mobile robot to be able to plan its path towards some target destination. Okay, and then for this class, we are going to focus on the wheel-based navigation, which implementing the differential steering system. Okay, now what is differential steering system? So differential steering system is a vehicle that having differentially steered drive system. Okay, so in this case, in your mobile platform, you have two tires, and then these tires is connected directly to different motors or different actuators. So when these two wheels fixed or mounted on a single axis and are independently powered and controlled, which is controlled by different motors, in providing both driving and steering functions to that mobile robot. So it means that you can determine the speed of the motor individually, okay, or you can set a different speed of velocity of the motor individually. So for example, okay, if this mobile robot has a same velocity left and right with the same direction, okay, for example, both tires are moving into forward direction, okay, or into upright direction. So in this case, you are going to have a same velocity or same speed, which in your controller or in your Arduino code, you can give the same PWM values. Okay, when you give the same PWM value with the same direction, your mobile robot will move forward, right? But what if you have a different speed but still in the same direction? So in this case, if you have different speed, which is, for example, the left speed is greater than the right speed, or the right speed is greater than the left speed, okay, but still in the same direction. So with this condition, okay, your mobile robot will steer to the opposite side, right? For example, if you the speed on the left is greater than the right, so the mobile robot has the intention to steer to the right. Okay, if the speed on the right is greater than the speed on the left, so the mobile robot has the ability to steer to the left. Okay, so what happens if one wheel turns faster but in a different direction? Okay, for example, in this case, you have a greater speed in your left tire than the right tire, but with a different direction. Okay, so for example, your left tire is moving upright, but your right tire is moving downright. So what happened? So your mobile robot will spin at the point, right? So now we look into the navigation technique. The first navigation technique is using the open loop system. In open loop system, there is no sensors has been adopted. Okay, so when there is no sensors, so the physical parameters that are available in the environment cannot be captured and cannot be used to determine the robot position. So this is the open loop system. Okay, so the open loop system, you have the input. For example, you want your mobile robot to move forward, so you just give signal to the controller, and then the controller will invoke another signals to the actuators, and the actuators will just produce the forward motion. But in your environment, in your surrounding, there are information that you can use to determine the position of the robot. But in open loop system, since there is no sensors, and therefore this information are not being used. Okay, so in this technique we are going to use an approximation technique which could provide the robot position but with some limited in the degrees of accurateness. Okay, so meaning that you can still navigate, you can still move your mobile robot autonomously in the environment without using any sensors, but the accuracy of that navigation process is doubtful. So the idea is to measure the distance of the robot move relative to the time it takes at a specific speed. So in this case, we are going to use this function or distance function. So distance function, we know it is the product of speed and time. Okay, so when you have a constant speed, you can measure the relative time taken for the mobile robot to move in a certain distance. Okay, so the speed of the mobile robot is proportional to the amount of voltage supplied to the motor. Accordingly, the voltage is generated using a PWM control signal where its duty cycle determine the voltage output. So this one we have covered in our previous chapter. So if you are going to have a greater speed, you need to increase the voltage of the motor, or you need to supply more power to the motor. So in order to supply that more power, you need to increase the value of the PWM values. So give a fixed duty cycle to produce a fixed speed, and you may work out the time taken to determine the distance traveled. Okay, so this is the first technique in making sure that your robot can autonomously navigate in the environment without using any sensors. Okay, by using the approximation technique. So for example, you want to move your robot in this direction. Okay, so your mobile robot will move forward for 12 seconds, then make a turn, and then move forward for another 13 seconds, and then after that it will make a turn and then move forward for another 12.5 seconds before it reaches its final destination. So in your control program, these are the things that you need to write in your code. Okay, move forward with a fixed velocity. Okay, and then delay for 12 seconds. So after the 12 seconds has ended, it will turn right. Okay, so to turn right, so you have to specify the speed of the left tire is greater than the right tire. For example, you give left tire with 50 and then on the right tire with 0. So you put some delay here because the system needs some time to turn. Okay, when it has turned to right, so you need to move forward for 13 seconds. Okay, with the same velocity or same speed. Okay, and then when you have done your 13 seconds, you need to make another right turn. Okay, and then during that turn process, you need to delay for a few seconds, and then you need to move forward until 12.5 seconds has finished or completed, and then you need to stop your mobile robot. To stop your mobile robot, you just give 0 values to the both tire. Right, so this is the control program. If you're using a delay, okay, in navigation, in your mobile robot navigation. So in this case, it still can move autonomously using software delay loops or using delay, but the accuracy is questionable. And therefore, we need a closed loop system. Okay, so in the closed loop system, suitable sensors are used, okay, to solve the accuracy problem in that open loop system. So in this case, okay, instead of just having an open loop system, right now you have added sensors in your system, which these sensors will capture the data from the environment. So for example, it can capture the position, the orientation, speed, for example, right? And then it will feed back to the controller. It will give some sensors that can be feedback to the controller, and then the controller will measure the error, and then it will produce some correction or corrective action here. Okay, so that the actuator will move back to its initial input. Okay, so sensors are used for more precise navigation. And then in line following robot, the sensor is used to detect and follow a line. Okay, so please remember, in your following robot, the sensors is used to detect and follow a line. So there are two tasks to be done by the sensor. The first one is to detect the line, and the second one, when it has detected the line, it must follow the line. So the line follower mobile robots can apply sensors that detect line either with a white line on a dark background. Okay, so the white line reflects more lights to the light detector, or dark line on a white background. So the dark line reflects less light to the light detector. Okay, so this is the example of the optical sensors that can be used to detect the line. And then normally we use the infrared sensors to detect the white background and black line. So in these sensors, there are two inputs, which is the transmitter and receiver. So the transmitter will transmit the light onto the surface, and then the light will be reflected back, and the receiver will capture the reflected light, and it will determine whether that light is actually coming from the white or black background. So this is just a suggestion. If let's say you want to use two optical sensors in your line following technique, okay, so you need actually more than one optical sensors, because one optical sensor is not enough, and it will give you a less degree of accuracy. So two sensors are sufficient, but if you use more than two sensors, it could possibly produce a better result. Okay, so this is just a suggestion example. You can actually put two sensors on your mobile robot, which these sensors must be the black line must be put in between of the sensors. Okay, so in this case, both sensors should detect the white background with the assumption that the black line is in the middle of these two sensors. And then let's say when the black line is detected, it will give the low signal to the Arduino, and when the white background is detected, a high signal will be given to the Arduino. Okay, so for ideal case, both sensors should give high value to the Arduino, should be on. Okay, so meaning that the robot is properly aligned with the line and may move straight. Okay, so when this condition happens, so it means that the robot is properly aligned with the black line, and it will move straight. Okay, so along the way or along the navigation process, the robot may sway to either side of the line. For example, if let's say it sways to the right, okay, so the alignment of the sensors currently has changed. So in this case, the left sensor has detected the black line, and therefore the signal become off and on. Okay, off for left sensor and on for right sensor. So meaning that for the left sensor, it detects black, and for the right sensor, it detects white. And therefore, with this condition, we know that the mobile robot has been swayed to the right direction. Okay, so you need to do this control motion in order to move back on the original path. So the robot must be forced to get back to its ideal condition by making a slight left turn. Okay, to make a slight left turn, you can increase the speed at the right tire, and then you can put a lower speed on your left tire. Okay, so with this condition, your mobile robot will sway back to left and move back to its original position. So the same method can be used when the robot sway to the left of the line. Okay. So from the condition, you may construct a table to ease your programming. So there are 3 permissible conditions. So these are the conditions that you have covered in those 2 sensors implementation. So if left sensor and right sensor both are on, so meaning that both sensors are on the white surface, and then the action that can be coming out from this condition is moving straight for the mobile robot. If either of the sensor is off, so meaning that it has been already swayed to the other side of the line, and then the action of the motor, it need to adjust the mobile robot back to the original position, either adjust to the left or adjust to the right. So the conclusion, the control should be performed by targeting the black line to always lie in between the 2 sensors, and both sensors with the white area, and then give both on status. Okay, so when any sensor sends a black line, so the controller should control the robot to slow down or even to stop and adjust accordingly. Okay, so these are the conclusions that can be made by these permissible conditions. Okay, so before you start your coding, you can draft your programming flowchart. Okay, now before we can start writing our code, it is advisable for you to draft your flowchart first. Okay, and then to draft this flowchart, you can always refer to the truth table that has been outlined before. Okay, you just follow the table. Okay, and then from that table, we know whether we have covered all the conditions that can be covered in our implementation. Okay, for example, in this, you already declare all the variables before the condition, right? Okay, so for example, when the left sensor is 0, meaning that it detects black line, and the sensor right is 1, meaning that sensor right detects white background. So when this happens, you know that the mobile robot has been swayed to the left of the line. Okay, and a correction action need to be done by adjusting the mobile robot towards back its original position. So to do that, you have to make a slight turn, okay, to adjust the robot. Okay, otherwise, if let's say this condition is not true, then you move to another condition. So you will check the condition, and then when it is not true, you move to another condition. Okay, when it is true, then you go to that function, particular function, to adjust accordingly. Okay, and so that the mobile robot will move back to its original path, or will move back to its original position. So after you have drafted your flowchart, only then you can write your code. Okay, from your flowchart, you can write your code. Okay, so this is example of Arduino programming by using if then else to write those conditions and then do the necessary function when the condition is true. Okay, so if you change the hardware implementation, definitely the control strategy will be different. For example, you are going to use 3 sensors, and then you put 1 infrared sensor in the middle of the line. Okay, so meaning that you have 3 sensors now. So in this case, the control should be performed by targeting the black line to always lie under the middle sensor, and the ideal condition for this position is on, off, on. Okay, so meaning that left sensor detects white background, while the middle sensor detects black line, and the right sensor detects the white background. So from this target, you must come out with a truth table. Okay, so you must specify the robot condition on that certain particular sensor status, and then according to that condition, you need to do some action to adjust the necessary action to be taken when the robot has been swayed to right or left, okay, or maybe the robot has been going out nowhere in your testing platform. So with this condition, with the truth table, you know whether you have covered all the conditions that could be possibly affect the navigation of the robot. Okay, so hopefully with this navigation technique, it will give you some idea, okay, how to perform the navigation process for your mobile robot later on. So for this topic, we just only cover for the line following robot. Actually, we can still manipulate many other sensors, for example, like obstacle detection sensors, like ultrasonic sensors, okay, to perform the autonomous navigation for our mobile robot. Okay, so after this, we are going to meet in the assignment and lab, and I will meet you again in the next topic. Okay, thank you.